In this video, we are going to discuss Cramer's rule for solving systems of linear equations with three variables. Let's start with this question. Given the system of equations that's x minus 2y plus z equal to 0, 2x plus 2y minus 5z equal to 5, 2x minus 3z equal to 3, use Cramer's rule to solve for x, y, and z. Cramer's rule states that x equal to dx divided by d, where d is the determinant of a matrix formed by taking the coefficients of the variables, and dx is the determinant of a matrix formed by taking the coefficients of variables y and z and replacing the coefficients of x by elements of the constant column vector. When we say constant column vector, we mean that elements to the right of equality sign. By the same analogy, y equal to dy divided by d, where dy is the determinant of the coefficient matrix, of which the coefficients of y are replaced by the corresponding elements of constant column vector, and z equal to dz divided by d, where dz is the determinant of a coefficient matrix, of which the coefficients of z are replaced by the corresponding elements of the constant column vector. Now, what we have to do is to solve for d, d sub x, d sub y, and d sub z before going to form a coefficient matrix for the system of equations of the form like this. It's advisable to make the following minor changes. The first change, reinstate y to the third equation by using 0 as its coefficient. The reason is simple, because the determinant of a matrix is solvable only for square matrices. The second change, interchange equation 1 and equation 3. I will tell you the reason for this change later. So let's rewrite the equation. 2x plus 0y minus 3z equal to 3. This is the same as equation 3 because 0y is 0. 0 plus any expression is the expression itself. 2x plus 2y minus 5z equal to 5. And x minus 2y plus z equal to 0. Next, let's formulate the determinant of the coefficient matrix, meaning d equal to the determinant of this 3 by 3 coefficient matrix. In the first equation, the coefficient of x is 2, the coefficient of y is 0, and the coefficient of z is negative 3. In the second equation, the coefficient of x is again 2, the coefficient of y is 2 again, and the coefficient of z is negative 5. When we come to the third equation, the coefficient of x is 1 because x means 1 times x. The coefficient of y is negative 2 and the coefficient of z is 1. For solving the determinant of this 3 by 3 matrix, let's use row 1 elements as the coefficients of the 2 by 2 matrix we are gonna form. Then let's assign positive and negative signs to the coefficients alternatively starting from row 1 column 1 position, meaning the sign of this 2 is positive, the sign of 0 is negative, and the sign of negative 3 is positive. So the determinant of this 3 by 3 matrix is equal to 2 times the determinant of the first 2 by 2 matrix. The sign of 0 is negative, so minus 0 times the determinant of the second 2 by 2 matrix. No need to find the values of the second 2 by 2 matrix because its coefficient is 0 and 0 times any number is simply 0. This is our reason for interchanging equation 1 and equation 3, meaning choosing the row containing 0 is advantageous because it shortens the steps we are going through. The sign of negative 3 is positive, so plus negative 3 times the determinant of the third 2 by 2 matrix. Let's figure out the elements of this 2 by 2 matrix. 2 is in row 1 and column 1. Crossing them out left us with these 4 elements. Negative 3 is in row 1 and column 3. Eliminating row 1 and column 3 will give us 2 in row 1 and 1 negative 2 in row 2 of the 2 by 2 matrix. This equal to 2 times the determinant of 2 by 2 matrix is simply the product of the main diagonal elements minus the product of the remaining 2 elements. That's 2 times 1 minus negative 2 times negative 5 minus 3 times the determinant of this 2 by 2 matrix is 2 times negative 2 minus 1 times 2, which is equal to 2 times 1 is 2 minus Negative 2 times negative 5 is 10 minus 3 times 2 times negative 2 is negative 4 minus 1 times 2 is 2, which is equal to 2 times 2 minus 10 is negative 8 minus 3 times negative 4 minus 2 is negative 6, which is equal to 2 times negative 8 is negative 16. Negative 3 times negative 6 is positive 18, which is equal to negative 16 plus 18 is 2. Thus, the determinant of the coefficient matrix is 2. To solve for d sub x, take the coefficient matrix and then replace the coefficients of x by the corresponding constant terms, meaning replace this 2 by this 3, this second 2 by this 5, and this one by this 0. Again, it's advisable to use row 1 elements as the coefficients of the 2 by 2 matrix we are gonna for. As usual, the sign of the first element is positive, the second element is negative, and the third element is positive. Hence, the determinant of this 3 by 3 matrix is equal to 3 times the determinant of the first 2 by 2 matrix minus 0 plus negative 3 times the determinant of the third 2 by 2 matrix. This 3 is in row 1 and column 1. Crossing these 2 left us with 2 negative 5 in the first row and negative 2 1 in the second row. Negative 3 is located in row 1 and column 3. Removing first row and third column gives us 5 2 in the first row and 0 negative 2 in the second row, which is equal to 3 times 2 times 1 minus negative 2 times negative 5 minus 3 times 5 times negative 2 minus 0 times 2, which is equal to 3 times 2 times 1 is 2 minus negative 2 times negative 5 is 10 minus 3 times 5 times negative 2 is negative 10 minus 0 times 2 is 0, which is equal to 3 times 2 minus 10 is negative 8 minus 3 times negative 10 minus 0 is negative 10, which is equal to 3 times negative 8 is negative 24. Negative 3 times negative 10 is positive 30. Again, this is equal to negative 24 plus 30 gives us 6. Therefore, d sub x equal to 6. Again, to solve for dy, we have to take the coefficient matrix and then replace the coefficients of y by the elements of the constant column vector. For this matrix, it's good to use row 3 elements as the coefficient of the 2 by 2 matrix we are gonna for, because this 0 helps us to shorten the steps we will be going. To assign the sign of the coefficients as positive and negative, we have to start by assigning positive to row 1 column 1 position and make positive and negative signs alternatively down column 1. The sign of the first element of row 3 is positive, so the second element is negative, and the third element is positive. Hence, the determinant of this 3 by 3 matrix equal to 1 times the determinant of the first 2 by 2 matrix minus 0 plus 1 times the determinant of the third 2 by 2 matrix. 1 times this determinant is the determinant itself, that's 3 times negative 5 minus 5 times negative 3, plus also 1 times this determinant is the determinant itself, that's 2 times 5 minus 2 times 3, which is equal to 3 times negative 5 is negative 15 minus 5 times negative 3 is again negative 15 plus 2 times 5 is 10 minus 2 times 3 is 6, which is equal to negative 15 minus negative 15 means plus 15 plus 10 minus 6 is 4, which is equal to negative 15 plus 15 is 0. 0 plus 4 gives us 4. Therefore, the determinant, that's d sub y equal to 4. To solve for d sub z, again, let's take the coefficient matrix and replace the coefficients of z by the elements of the constant column vector. Let's use row 1 elements as the coefficients of the 2 by 2 matrix we are gonna for and assign their signs as positive, negative, and positive. So the determinant of the matrix equal to 2 times the determinant of the first 2 by 2 matrix minus 0 plus 3 times the determinant of this third 2 by 2 matrix. 2 is located in row 1 and column 1. So eliminating these 2 leaves us with 2, 5 in the first row and negative 2, 0 in the second row. 3 is located in row 1 and column 3. Crossing them out left us with these 4 elements, which is equal to 2 times 0 minus negative 2 times 5 plus 3 times 2 times negative 2 minus 1 times 2, which is equal to 2 times 0 is 0 minus negative 2 times 5 is negative 10 plus 3 times 2 times negative 2 is negative 4 minus 1 times 2 is 2, which is again equal to 2 times 0 minus negative 10 means 0 plus 10. 0 plus 10 is simply 10 plus 3 times negative 4 minus 2 is negative 6, which is equal to 2 times 10 is 20. Positive 3 times negative 6 is negative 18, which is again equal to 20 minus 18 equal to 2, meaning d sub z equal to 2. At this stage, we calculated all the 4 determinants. What left is to solve the values of x, y, and z. X equal to d sub x divided by d, which is equal to d sub x is 6 divided by d is 2. 6 divided by 2 gives us 3. Y equal to d sub y divided by d, which is equal to d sub y is 4 divided by d is 2. 4 divided by 2 gives us 2. The third variable z equal to d sub z divided by d, which is equal to d sub z is 2 divided by d is 2. 2 divided by 2 is 1. Therefore, the solution set equal to x is 3, y is 2, and z is 1. By this, I conclude part 15. Please subscribe, like, and share the page. Bye-bye.